Hi everyone and welcome back to Dev Portal, your go-to channel for mastering Java programming. In today's tutorial, we are going to explore the internal implementation of two of the Java most popular data structures, ArrayList and LinkedList. We will break down how they work internally, discuss their time complexities for common operations, and help you to decide when we need to use one over the other. Let's jump right in. Before diving into the internal mechanism, let's briefly revisit what ArrayList and LinkedList are. Both of them are part of Java collection framework and implements the list interface. But their internal implementations make them behave very differently, especially when it comes to performance. So understanding this difference is key to choosing the right one for your specific use case. Let's start with the ArrayList. Internally, an ArrayList in Java is based on a dynamic array. This is similar to regular array, but it can grow or shrink dynamically as we add the or remove the elements in the runtime. So let's discuss some of the key aspects of ArrayList first. When we create an ArrayList, it starts with a default initial capacity, usually 10. As we keep on adding the elements in the ArrayList, it will track the number of elements we have added. When the internal array runs out of space, it creates a new array that is 1.5 times the previous size. Copies all the elements to the new array and discard the old one. This resizing operations will take big O of n notation of time since all the elements need to be copied. Let me explain you in a simple way. Suppose you have created an empty list in Java, that is the array list. Then initial capacity will be the 10, and suppose when you have added 10 elements it is fine, but once you are going to add the 11th element, what it will do, it will create another array first of size 1.5 times the previous one. So initial size was 10, so the new size will be the 15, and it will copy all the elements from the previous array to the new array, and then it will discard the previous one and add the 11th element into the new array, and our object will refer to that reference now. So let me show you how it is implemented in Java as well. So let me write array list, and it is a string. List is equal to new array list. Let me import, and if I open this array list class, you can see they are implementing the list interface. And if you can see at line number 118 the default capacity is 10, which we have already mentioned. And if I go a little bit down, so here we go at 168, you can see it is creating the empty array list with default capacity of 10. It means with 10 initial capacity it will create the array list. And if I open this element data, you can see it is creating array of object. Once you initialize your array list, it will create this empty array list, and you will be able to add the 10 elements. When you are going to add the 11th element, what it will do, it will create another array of object. It will copy all the elements from the previous one to the new one, and it will add the 11th value here, and your object will refer to that new array reference. Don't get confused with the initial capacity with the size of that array list. The size of the array list is the number of elements you have added in your list, and when we talk about the initial capacity, it is just for that JVM reference, so that it know that what is the size of that array it needs to create. Now let's discuss some of the other key aspect of array list. One is that array list use a continuous block of memory. Accessing element by using the index is very fast. It will take big O of 1 time complexity. This makes ArrayList ideal for scenario where we need quick access to elements using index. Now let's look at a small example to understand in a better way. Let me close this first, and this example I have already explained in my previous tutorial as well. So what I will do, I will add few elements here, list.add, and let me add first bread. And same way I will add few more elements. Suppose let me add milk, and let me add eggs. If I add sysout statement, let me print this list. Let me save this code, and you can see that it is printing the elements of the array list, and it will print in the order of insertion you have done. Now if I try to remove any element, list.remove, and if I give the index 0 and sysout list, let me print. So you can see in the screen it has removed the bread, and now it is printing milk and eggs. If I show you the size of this list, sysout list.size, then it will print 2, not 10. So this is one thing you need to remember. In this example, we are adding elements in the end of the list, so the time complexity is big of 1 annotation. But removing or inserting elements in the middle of the array list can take big of n notation time complexity, since elements may need to be shifted to maintain the order. Now let's discuss some of the advantages of the array list. First is that fast random access due to contiguous memory. Because of that, it will reduce the time complexity to big of 1, and efficient for stable data where we need mostly perform read operations. If we talk about the disadvantages, then expensive to remove or insert elements in the middle of the list, because it will take big of n annotation of the time complexity, and need to be resized and copy the elements if the internal capacity is reached, which can be costly. So an array list is great for this scenario where we need fast random access and the majority of the operations happen at the end of the list. Now let's shift our gears to discuss about the linked list. Unlike array list, a linked list in Java is based on doubly linked list. Each element in linked list is stored in form of node, which contain the element data and 2 references, one for the previous node and one for the next node. Let me show you that as well. So let me remove this code, and what I will do, let me add linked list. It will be the string list is equal to new linked list. Let me import, and if I open this class, so you can see it is also implementing list interface. And if I go a little bit down here, you can see they have created node. In a linked list, each element is a node. A node contains the data and a reference to the previous node and a reference to the next node. This allows linked list to handle insertion and deletion efficiently. Now if we talk about insertion and deletion, because linked list use nodes, adding or removing element at the beginning or in the end is very quick. That will take big of 1 annotation time complexity if we have the reference of the node. Unlike array list, accessing an element by using the index in a linked list is slower because it requires traversing the node sequentially from the beginning to the end, making it a time complexity of big O of n. Now let's see a small example of linked list as well. So first let me close this classes, and what I will do, I will add few elements here. List.add go to bath, and same way let me add few more elements. List add wash your clothes, and one more element I will add. List.add go to sleep. Now let me add sysout statement to print these values of the list, and if I run this code, you can see it is printing again. The insertion order will be maintained. Now if few more methods which linked list provide to us are, we can delete the element from the beginning or in the end, and we can see the element from beginning and the end as well. Few more methods that linked list provide to us are the remove first and add first, which will remove and add the element from the end and beginning of the list, and same way we can see the first element and last element of the linked list as well. These methods already I have explained in my previous tutorial. Link I will give you in the I section, you can check it out. So now what I will do, I will try to remove one element. Remove first. So it will remove the first element of the list, and now let me print list here. Let me save the code, and you can see it has removed go to bath, and now it is only printing wash your clothes and go to sleep. So now let's discuss about the advantages of the linked list. Linked list provide fast insertion and deletion in the beginning or in the end of the list because already it has the reference. Next, no resizing is needed since it does not use the contiguous memory of array. If we talk about the disadvantages, then it is slow random access. It will take big of n time, making it less efficient to retrieving element using the index, and high memory overhead due to storing additional pointers. Like for each node, we are storing previous node as well and next node pointer as well. Due to these characteristics, linked list is ideal for scenario where we need to frequently add and remove element from the list, especially in the beginning or in the end. Choose ArrayList if you need fast access by index and the data does not change frequently. Choose linked list if you need to frequently add or remove element, especially in the beginning or in the end of the list. Let's quickly cover some practical scenarios where each data structure is a better choice. Use ArrayList for tasks like maintaining a list of items in a shopping cart, where the order is important and we need to access elements by index. And we can use linked list for tasks like implementing a queue or managing a playlist, where adding or removing element from the start or in the end is common. That's it for today's video. We have covered how ArrayList and linked list work, discussed time complexity, and gave you some guidelines on when to use each. If you found this tutorial helpful, please give it a thumbs up and subscribe to Dev Portal for more Java concept. Don't forget to hit the bell icon so that you will get updated to the latest content that we have uploaded. Feel free to leave your questions or suggestions in the comments section below. Thanks for watching, and I will see you in the next video.